I'm Nicholas Wilson.
And our project is preserving landscapes using naturally occurring resources.
The project was focused around the idea of soil erosion. The purpose of this project was to find ways to prevent soil erosion in home landscapes.
The research hypothesis states that when angles and barrier types are changed on models and actual landscapes, the difference in water and soil retention will be abstract. We predict that the model with the greatest slope will require more significant amendments than those with smaller angles of slope to retain soil and reduce runoff.
Believe it or not, soil is extremely important in our lives. It is necessary to find ways to protect soil from erosion in both an agricultural and commercial setting. Soil provides food for humans and other animals and is a major part of our economy.
Many landscapes contain sloping elevations within the property, making them more susceptible to soil erosion. This is especially significant during heavy rain. Soil erosion is caused by many different factors in the environment. Most of these we cannot control. Some factors include water runoff from sudden rainfall, fast water speed, and the overall state of the soil.
Soil erosion causes deforestation, alters ecosystems, and devalues property.
Many landscapes contain sloping elevations within the property, making them more susceptible to soil. The amount of erosion depends on three factors. They are the quantity of water, the speed of the water, and the state of the soil.
We created models of landscape with varying inclines that determine the speed of water flow. The inclines served as landscape angles, and these inclines were 30, 60, and 80 degrees.
We then added natural resources. These were leaves, sticks, rocks, and tree cuttings. These served as our natural barriers to the soil.
To test for water retention, we drilled holes in the bottom of the planer box to allow water flow to flow from the soil. We then caught the water in a container and measured it.
We then dispersed some fast plant seeds in the soil. This demonstrated soil erosion and relocation.
And after performing the experiment, we observed that as incline increased with the addition of amendments, the amount of water absorbed by the soil increased as well. And also the distance the seeds traveled decreased.